cross-validation for longitudinal datasets with unstable correlations. Cross-validation, or CV methods, are widely used for machine learning model development. They select hyperparameters corresponding to models with the lowest estimated error, and they estimate this error by sampling multiple validation sets from the training data, either randomly or temporally, and averaging model performance across these sets. However, this averaging can mask a model's reliance on unstable correlations, temporary relationships between inputs and outputs that do not hold over time. An example of such a correlation is that between hematocrit measured via an arterial blood gas test, or HCT and ABG, and clinical deterioration. HCT and ABG was found to be predictive of clinical deterioration in Michigan medicine during the height of the COVID-19 pandemic due to a temporary triaging policy, but was not predictive before and after that time period. Relying on unstable correlations can result in poor generalization over time. However, random and block CV often result in models that rely on these correlations. And to illustrate, consider two features, one with a stable correlation with the outcome over time, in blue, and one with an unstable correlation, in orange. Ideally, CV methods should estimate a lower average loss for a model relying on the stable feature versus the unstable feature. However, random and block CV do not do so. The key insight informing our proposed approach comes from segmenting results not by method but by model, and when we do so, we find that random and block CV estimate the same average loss for the stable model, but different average losses for the unstable model. Thus, our proposed approach is selecting models whose absolute difference in estimated loss between block and random CV is minimized. We evaluate the models selected by our approach against those selected by block and random CV on a real data task with unstable correlations, using a UROC where higher is better, and we find that before 2003, the models selected by our method performed slightly worse, but after 2003, they significantly outperformed those chosen by baseline methods. So while there's a within-year trade-off, our approach yields models with a higher average and more stable performance over time. Here's a summary of our contributions and a link to our codebase, and thanks for listening.